In this video, we are going to take up one more problem. The problem number 3. A straight bar of 500 mm length has its cross-sectional area of 500 mm square. Find the magnitude of the compressive load under which it will decrease its length by 0.2 mm. Take E for the bar material as 200 GPa. Now, the data given is the length of bar is 500 mm. Then has its cross-sectional area and decrease in length is delta L, which is 0.2. And then we have the modulus of elasticity as E, 200 GPa, which will be equal to 200 into 10 to the power of 3 Newton per mm square. And then the area of cross-section of bar, A, capital A, is 500 mm square. Then what is strain? Because you have the decrease in length and you know the length of the bar, so you can easily find out the strain, which is decrease in length by the original length of the bar, which is delta L by L. So substituting the value of delta L and L, which is 0.2 divided by 500. So on simplification, you are going to get that value as 4 into 10 to the power of minus 4. Then we know the stress, we know the strain, we know the Young's modulus, so we can directly find out the stress. So what is Young's modulus? Young's modulus is given by E, which will be equal to stress by strain, which is equal to sigma by epsilon. Substituting the value of Young's modulus as 200 into 10 to the power of 3 equals the stress which we need to find out divided by the strain, which is 4 into 10 to the power of minus 4, which is the calculated value. So on cross multiplication, you will going to get the value of stress as sigma equals 80 Newton per mm square. Once you get the value of stress, we know what is the stress, which is applied compressive load divided by the cross-sectional area of the bar. So what is the applied compressive load, which is P by capital A? We know the value, calculated value of stress. We know the area of the cross-sectional bar, so we can find out the applied compressive load. So substitute the value of stress as 80 equals P by cross-sectional area of the bar, which is A, which is 500. So on cross multiplication, P is equal to 80 into 500, which will be equal to 40,000 Newton, which will be equal to 40 kilonewton. Therefore, the compressive load which need to be found out in this problem, which is P, will be equal to 40 kilonewton. Or we can also find out the decrease in length, which is delta L, will be equal to P into L by A into E. We know the value of delta L, we know the value of length, we know the area of cross section, and we know the Young's modulus. So what is delta L, which is equal to 0.2, which is equal to P, which I need to find out, P into 500 divided by area is 500 into 200 into 10 to the power of 3. So on simplification, you will going to get the compressive load as 40 kilonewton. So this is how you will be able to solve this particular problem. Now we take up one more problem. A brass rod of 1.5 meter long and 20 mm diameter was found to deform by 1.9 mm under a tensile load of 40 kilonewton. Calculate the modulus of elasticity of the rod. So as we know, the length of the rod is given as 1.5 meters, so which is equal to 1.5 into 10 to the power of 3 mm. So that will be equal to 1500 mm. So then we know the diameter of the rod, which is equal to 20 mm. So deform is found to deformation of the rod, which is delta L, will be equal to 1.9 mm. So under the tensile load, which is P, that is applied tensile load, which is capital P, is equal to 40 kilonewton, which is nothing but 40 into 10 to the power of 3 Newton. So what I need to find out is we need to find out the modulus of elasticity of the rod E. So what is the area of cross section of the rod? As is given the diameter of the rod as 20, capital A will be equal to pi d square by 4, which will be equal to pi by 4 into 20 square. On calculation, this value, you will going to get it as 314.16 mm square. So what is the stress? Stress is nothing but applied tensile load by the area of cross section of the rod. Applied tensile load is 40 into P by A, which is equal to 40 into 10 to the power of 3 divided by 314.16. On simplification, by calculating these values, you will going to get that value as 127.324 Newton per mm square. Now, then what is strain? Strain is nothing but deformation of the rod divided by the original length of the rod, which will be equal to delta L by L. So what is delta L? You know the value of delta L is 1.9 divided by the original length of the rod, which will be 1500. That is equal to 1.2667 into 10 to the power of minus 3. So that is the strain value. So what is Young's modulus? Young's modulus is nothing but the stress by strain, which is sigma by epsilon. You substitute the value of calculated value of sigma by epsilon, you can get directly the Young's modulus. So that is 127.324 divided by 1.2667 into 10 to the power of minus 3. On calculation, that is by simplification, you will going to get it as 100.5 into 10 to the power of 3 Newton per mm square, that is equal to 100.5 GPa. That is E approximately will be equal to 100 GPa. So, or we can also find out by using the deformation of the rod delta L, which will be equal to P into L by A into E. You know, this delta L is 1.9, which is equal to P is 40 into 10 to the power of 3 into L is 1500 divided by area of cross section is 314.16 into E, which is the one which you need to calculate. On Young's modulus, on simplification, you will going to get it as 100.5 into 10 to the power of 3 Newton per mm square. In other words, E will be equal to 100.5 GPa, or it can also be equal to 100 GPa. So this is how you will be able to solve this particular problem. If you like this video, please subscribe to my channel. Thank you.